Okay, welcome back everyone. In this video, we're just going to review the major kinematic equations of motion, and I'll show you how to use one of them to solve one of your homework problems. So, the four that we should keep in mind are these. Alright, first one. This one has to do with average velocity or speed. V average is equal to V final plus V initial divided by 2. And that's kind of silly, but that's the definition of average. I should also point out that this could be a speed or a velocity. If it's a velocity, make sure you're very careful about the sign. So if it's going, for example, in a positive direction to start with, and then ends up in a negative direction, so if VO, V initial, is plus 10, but V final is negative 20, well then V average is going to be negative 20 plus 10 divided by 2, or negative 5. So that's very important. Second one, this is the so-called acceleration equation. V final is equal to V initial plus acceleration times time. I should also point out that sometimes you've seen me write V initial with an I. It's the same thing as with a little zero. Technically, that's V naught, which is like 0. And this equation we're very familiar with. We've worked with this before. It comes from the definition of acceleration as a change in velocity over a change in time. That's where that one comes from. The third equation is the so-called distance equation. X final equals X initial plus V initial times T plus 1/2 a T squared. So that's 1/2 acceleration times time squared. And sometimes what we'll do is we know that a change in position is final minus initial. So sometimes we'll simply write this as delta x equals V initial t plus 1/2 a T squared. And you'll recognize this from the Airtable Antics lab. We've got our two different types of motion in the two terms. And I'll leave it to you to try to remember what each of those correspond to. Then, the fourth equation is what I sometimes call the forgotten equation. And the reason I say it like that is just because people don't use it that often. They forget. And it's V final squared equals V initial squared plus 2 times acceleration times change in position, delta x. You can also use delta d, delta y, delta whatever you want to use for distance, anything. And instead of acceleration, remember that if something is falling, instead of a, you could also use g. So g is a type of acceleration for falling objects. Okay, so here's an example. A rifle bullet with a speed of 330 meters per second is fired directly into a dense material that stops the bullet in 25 centimeters. Assuming the bullet's deceleration to be constant, what is its magnitude? So this is one of your problems from set 3, so if you're paying attention, you could just copy. Ooh. So anyways, what do we know? We know 330 meters per second, so what is that? Well, let's actually go through our 4-step process. And step 1, remember, is to identify the knowns and the unknowns, and also to draw some sort of a diagram. Now I could draw a before or after, but it's not a big deal. Okay, so there's my bullet, it's speeding along, and here's the dense material that it's going to smash into, and I could write this, that this is my initial picture. Okay, so that's got a V initial, and then afterwards the bullet will be smashed in there, and it'll be in there a distance of 25 centimeters. And so what we want to do So v initial is 330 meters per second. We want to find the acceleration, which is deceleration. Okay, so here's everything that we know. Distance is 25 centimeters, or 0.25 meters. We know v initial is 330 meters per second. Now if it's coming to a stop, what does that tell us about v final? Well, it's just 0. And what we want to find is the acceleration. Okay, so step 2 of the 4-step process was to select the appropriate equation. So it's the appropriate equation, and in this case there's only one unknown. So maybe you'll have 2 unknowns in other problems, but for this one you just need to find the acceleration. So what equation do we have that has distance, velocity, initial, velocity final, and acceleration? Well, it turns out to be the forgotten equation. V final squared equals V initial squared plus 2a delta d. Okay, now are there other equations that could work for this? Yes, but it's going to take a lot longer to get to the answer. You're going to end up generating more unknowns. Step 3 is to rearrange what we have and to solve for the unknown. So what we want to find is the acceleration. So since we're trying to solve for acceleration, how about if we write it like this? V final squared minus V initial squared equals 2 times acceleration times change in distance. Then, because we want a, we can divide each side by 2 delta d, and we get acceleration is V final squared minus V initial squared, all divided by 2 delta d. Actually, I'm going to write it like this. Okay, now the 4th step, if you remember, is plug and chug and evaluate. So we have to make sure that this makes sense. Alright, we want acceleration, deceleration to be accurate, and so V final we said was 0 meters per second, that whole thing is squared, minus V initial is, well, let's take a look. Looks like 330, and it's a velocity, but let's just say that going to the right is positive, so it's going to be positive 330 meters per second quantity squared. Then we're going to divide that by 2 times the displacement, or the distance, and the distance is, in this case, 0.25 meters. So now you see the great thing about solving the equation first is you don't have to mess around with moving the units around, and it really makes it a lot easier to solve. So now we just do math, and that's going to cancel out. So I'm still going to have a negative sign, but 330 squared is 108,900, and the unit gets squared too. So the square goes to 330 and also to the unit. That is divided by, well, even I can do this one in my head, 0.50 meters. So the final step is to actually divide that out, and we're going to get negative 217,800 as the number. What about the units? Well, we have meters squared per second squared, and we're dividing that by meters. Hopefully you recognize by now that we just multiply by the reciprocal. One of those cancel, and holy cow, I have units of acceleration. Okay, so this is our answer, but now we're going to evaluate, and I think part of evaluating is applying Sig Figs to this. So let's go back and look at what we have. We're given V initial, which is 2 Sig Figs. Looks like distance is given to 2 Sig Figs. Okay, V final of 0 doesn't really count. 2 right here is a counting number, so the final answer should be negative 220,000 meters per second squared, or if you want to be fancy, negative 2.2 times 10 to the 5th meters per second squared. And that is our final answer.